So in Notes 4.6, we're getting back to functions. Can I determine functions and use function notation? So I want to go ahead and before we actually talk about function notation, I want to do an example that you've all seen before. And it just, we have this equation over here that just says y equals negative 3x plus 1. Then draw the line down the equal sign here. And it's actually telling me what x is. It's telling me it wants me to substitute 2 in for x. So let's do that. Always substitute in parentheses. And so if we want to get our y value, negative 3 times 2, make sure you use the correct order of operations, we get a negative 6 plus 1, and we get a negative 5. And we have just substituted. It told me what x was, it had me substitute it. Well, when we have function notation, it looks the same. It is the same, I should say. Instead of the y, what do we notice? It's called f of x. It's just stating it's a function. And instead of saying x equals 2, it's saying f of 2, meaning if you put an f of x above that, meaning put the 2 in where you see the x. And so we're doing the same process. Function notation is just a different way of writing it. Draw a line down the equal sign. Okay, instead of f of x, I'm okay if you write y, that's what it is. And we're going to plug in, we have negative 3 times 2 plus 1. So you can see that these are the exact same problems. One is just written as y equals, and it tells you what x is. The other one is written in what we call function notation. This is our function notation here, where it says f of x. That's the difference. That's it. Some examples that you might look at in your practice is it might show you f of x equals, and then it has a problem here. And then it has the semicolon, and it has in brackets 1, 2, 3, and 4. Well, this 1, 2, 3, and 4, this is your domain. And if we review what domain is, it's your x value. So it's saying plug these numbers in for x and get an answer for y. Substitute. So I always start, I made a table. So I'm going to plug my 1 in for x. So let's go ahead and start with that. If I plug my 1 in for x and I do my math, I'm going to get 2.5. So this answer would be 2.5. So 1, if x is 1, y is 2.5. Now we're just going to continue, and now we're going to plug in 2. So let's take our equation. We have our f of x, and instead of plugging in the 1, I'm plugging in the 2. Negative 1.5 times 2 would be a negative 3. Plus 4, you get a positive 1. So we're just substituting each time. That's all. It's just a different way of writing it. Let's not make it confusing. Now we're going to substitute in my 3. And if I plug 3 in and I do my math, I get negative 0.5. And last but not least, we need to substitute in our 4. And if we do the math, we're going to get a negative 2. So this is how function notation is written. I want you to think of it though as substitution. We have 4 slides here. Let's go on to the next one. And we talked about function notation a lot in these notes, but that's it. So let's talk about what a relation is. And we know that a relation is a pairing of numbers in one set. So I want to go ahead and talk about the different ways to represent relations. One way would be ordered pairs. X comma y, that is a way of representing a relation. We could have a table. We could have a graph. We've seen tables, graphs. We've seen ordered pairs. We could have an equation. We've been given a lot of equations. And the last one that will be new for you is what we call a mapping diagram. It's also called an arrow diagram. So these are ways that we can represent relations. Ways that we can represent relations. And so we're going to be talking about functions. We're going to look at all these relations in different ways, and we're going to determine if they're a function. So what is a function again? It's every input has exactly one output. And let's go ahead and write down again, what's that question that we're going to ask ourselves? And the question is, are all the x's different? Are all the x values different? That is our question that we're asking ourselves. And if we can answer yes to that question, then we do have a function. So we're going to start here with ordered pairs. We're going to look at our x's. Remember, the first part of our ordered pair is our x value. So I have a 6. I don't even have to look at the y's. I have a 4, I have a 6, and a 0. Are all your x values different? No. So this is not a function. And that's it. You're going to be determining functions here. We only need to look at those x's. Remember, every input or every x value has exactly one output or y value. So every x has exactly one y. And so we're looking at the x's. We looked at ordered pairs. Let's try to determine if we have a function based on a table. Let's look at our table here. Are all my x's different? Yes. So this is a function. Okay. So we do have a function here. Now I want to show you, I'm going to take my table and I'm going to create a mapping for you from this table so you can see what a mapping looks like. I'm going to talk about a couple functions with a mapping. With a mapping, we kind of have like these two ovals. The first one's the x, the second one's the y. It probably looks very similar to you to our table. And we are going to write out our x values, and they need to be in order. So we're going to write our values out in order. That is super important. So 0, 2, 4, 6, and 8. So we're going to write values in order. And we're going to write our y values also in order from I pick smallest to biggest. So we'll have a -4 and we'll have a 0. But what did you notice? We are not going to repeat a value. So do not repeat a value. For example, if I were to look at my table says -4, 0, -4, 0, -4. I'm only going to write the -4 one time. I'm only going to write the 0 one time. It's important for a mapping. And now for our mapping, we just connect lines to what they go with. So let's go ahead and look at 0, -4. So I'm going to draw a line to the 0, -4. And then I have the 2, 0. So I'm going to draw a line to the 2, 0. And then I have 4, -4. So I'm going to draw a line from the 4 to the -4. And 6, 0. So I'm going to draw a line. And 8, -4. And I'm going to draw a line. And you have just created a mapping. That's it. And again, if I want to determine if this is a function, we're going to look at our x values. And since we're not repeating a value, you need to ask yourselves, are all the x's different? Or I should say, do all my x values only have one line? And this is a function, and we know it's a function because we took the table above that was a function. So yes, this is a function. And how we can determine if it's a function from a mapping is we are looking for just one line to all the x's. That means that there is only one of them. And nothing repeats. We have one last example, and we're going to... From a table, we learned how to create a mapping. Write down that you write the values in order. Do not at a graph. And the graph can get a little tricky. There's two things we can look at with a graph. First of all, we know that our graph is made up of ordered pairs. So we could actually write these ordered pairs. And this first one here is -2, 0. And then we have a -2, -1. This one right here is the origin, so it's just 0, 0. And then we have a 1, 1. And we have a 2, 2. And so if we look at all of our x's, we can see that our x's here, our question is, are all the x's different? And the answer here would be no. These x values are the same. So this is no, not a function. But there's another way to determine if it is not a function. And it is called the vertical line test. And so what the vertical line test is if there are 2 points in one vertical line, the graph is not a function. And the reason the graph would not be a function is because that means that you have 2 x values. Look at this vertical line right here. That means that your x's are not all different. Remember, we want every x value to be different. So we talked about functions and how we can determine a function from a graph. We can use the vertical line test. How we can determine